Greetings, Algebra 2 students. This is Dr. Heron coming back to you with absolute value equations and inequalities. And this time we are graphing them based on kind of what the graph looks like. So what I am going to do is kind of break down what the general idea is. This will be the general form of the equation where the vertex is going to be h and k. That's supposed to be an h. So it's an h and k. Please notice it's minus h plus k, so you have to be careful with that, with those signs. And the shape is almost a perfect V, or I guess it could be open downward like that. If a is greater than 0, so that number is greater than 0, then it's going to open up. If it's negative, it's going to open down. And this right here is the simplest absolute value, function and graph there is, and we call that a parent function. Okay, we call that a parent function because every graph is some variation of that. I can flip it around, I can move it, I can stretch it, but it's going to be some variation of that. Okay, so if I'm looking for the vertex, all right, remember it goes x minus h plus k. So my vertex is h and k. So my vertex is going to be 2, 3. And because that is a positive number, it's going to open up. For letter B, there's nothing added out here. So this is like plus 0, and that's a positive 5. So it's going to be like h is negative 5 and k is 0. So it's going to be negative 5, 0. And because that's a negative, it's going to open down. So over here, I'm adding or subtracting nothing inside, but I've got this plus 7. So this is going to be like 0, 7. Okay, this is like if I had x minus h, but h is 0. And that one's going to open up. And this last one, minus h plus k, so it's going to be a positive 3 and negative 5. And because that's like a negative 1, it's going to open down. So now when I graph this, I want to start with where's my vertex. So in this case, my vertex, negative 1, negative 2, that's where I want to put that one in the middle. So then I'm going to go 2 up, and I'm going to go 2 down. Then I'm going to put that in there and look at what happens. So I end up with 0, negative 1, negative 1, 0. All right, so 1, negative 2, there's my vertex. 0, negative 1, negative 1, 2. So there, and there. There is my graph. All right, my domain is going to be all real numbers. Okay, I can keep adding values in for x anywhere I want. And my range is going to be, well, I bottom out at negative 2, and everything else is going to go up from there. So now let's look at these problems and just kind of get some practice with them. So my vertex is going to be 4, 1. Okay, so I put 4, 1 in there. Then I'm going to go with 2 down and 2 up. And when I put that value in there, like if I go 2 minus 4 plus 1, that's going to be 3. So it's going to go 3, 2, 1, 2, 3. And all I'm doing is substituting those in for x and figuring out what happens. All right. So 4, 1 is my vertex. 5, 2, 6, 3. There's my graph. So my domain, all real numbers. And my range is y is going to be greater than or equal to 1. Okay, so this next one, negative 2, negative 4. Remember, it goes x minus h plus k. So my vertex is going to end up being 2, negative 4. So if 2 is negative 4, so So I go 1, 0, 3, 4. So if I just substitute that in there, 1 minus 2 absolute value is going to be 1 minus 4. So that'll be negative 3. That'll be negative 3. That will be negative 2. That will be negative 2. So when I graph it, it's going to go 2, negative 4. And it's going to look like that. When there's nothing in front of the absolute value, when there's no 2 or anything, that, it's going to be a perfect V every time. So again, my domain, I can put anything I want in for x. My range is going to be y greater than or equal to negative 4. If you notice, it's always this number that goes with the vertex. It's the y value of the vertex. So now we get a little bit different look because there's a number in front of the absolute value. My vertex becomes 0, negative 3, okay? So there's my point. I start at 0, negative 3. So I go 2 up, 2 down. So then when I put that into my equation, negative 1 and 1 both get negative 1. 2 and negative 2 both get positive 1. So if you look, that V is a little bit skinnier. So once again, my domain is going to be all real numbers. And my range is going to be just everything greater than or equal to negative 3. Okay, so now let's change gears. These are just graphs. What happens when I throw in a absolute value inequality? Well, we're going to treat it pretty much the same. That means it's going to be solid. My vertex is going to be 2, 5. And because it's less than, I'm going to shade down. I'm going to shade in. I can always check my, I can always put in 0, 0 and see if that's a true statement. So when I do that, I substitute in 0. I get a positive 3. 1 gets a 4. 3 gets a 4. 4 gets a 3. So at 2, 5, 1, 4, 0, 3, 1, 4, 0, 3. Solid line. I open down because of that. So then, even if I test 0, 0, which I can, I know I'm going to shade down, but even if I want to test 0, 0, I can absolutely do that. Is 0 minus 2 absolute value plus 5 is 0 less than that. So is 0 less than negative 2 plus 5? Is 0 less than 3? Yes. So I'm going to shade in here. Okay, last problem. Vertex is going to be 0, 2. All right. Number in front is negative, so I'm going to shade down again. 0, 2, negative 1, negative 2, 1, 2. When I fill those in, all right, 1 becomes negative 1, and negative 1 up top for negative 1. Negative 2 becomes negative 4, negative 4. So, negative 1, negative 1, 1, negative 1, negative 2, negative 4, dotted line, because that is dotted. And then I'm actually, I'm going to make a correction here. I actually want to shade up because it's greater than. All right, so I can test. If I test 0, 0, watch what happens. Is 0 greater than 0 plus 2? Is 0 greater than 2? That is false. So I shade on the outside of 0, 0. And there's my answer. Okay, Be patient with this. Test out these points. That will give you a guide on which way to go. And we will talk soon.